Welcome back, Math Masters. A new scroll has arrived at the dojo gates. Today, you'll begin training to earn the Place Value Patterns badge. Consider these 6 numbers: 5,000,000, 500,000, 500, 5, 5/10, and 5/1000. How does the value of the digit 5 change in each number? What patterns do you notice as the digit 5 shifts places? How are these patterns connected to multiplying or dividing by powers of 10? Study well. The path to mastery begins now.
Welcome back, Math Masters. It's Jenna and Mia again. Wow, look at all these numbers. They all have the same digit, 5, but they all seem very different from each other. I have a feeling we'll need our knowledge of place value and powers of 10 to conquer today's challenge. Have your guided notes ready? Training starts now. To begin our studies, let's use the number 3,000. If we multiply 3,000 by 10, what do we get? 30,000. The 3 shifted to the left one place value when we multiplied by 10. The value of 30,000 is 10 times more than the value of 3,000. What if we multiply 3,000 by 100? This time, we get 300,000, and the digit 3 moved 2 places to the left. That's because it takes 2 tens, 10 times 10, to make 100. What about the value of the 3? 300,000 is 100 times the value of 3,000. So, the power of 10 we are multiplying by is how many times the value increases. What do you think will happen if we multiply 3,000 by 1,000? If it follows the same pattern, the digit 3 will shift to the left how many places? 3. 3,000 times 1,000 is 3,000,000. We were right. The number 1,000 is made of 3 tens, 10 times 10 times 10. So the digit moved 3 times, and the value is now 1,000 more than where we started. Do you think the same pattern will be true for decimal numbers? For this example, we're starting with the number 3,000ths. Let's apply the same powers of 10, 100, and 1,000 to this decimal and see if we notice the same pattern. Pause here and try multiplying in your guided notes. Did you notice the same thing happening? Just like with whole numbers, each time we multiply by a power of 10, the digit 3 moves to the left. Once for 10, twice for 100, and 3 times for 1,000. This is just like a training tip we've learned before. The number of place value jumps matches the number of zeros in the number we multiply or divide by. So, 3,000ths times 10 equals 300ths. If we multiply by 100, we get 3/10ths, and if we multiply by 1,000, we get the whole number 3. Great work! When we multiplied by powers of 10, the values of the numbers increased. What do you think will happen if we divide instead? Let's start with the same number, 3,000, but this time we'll divide by powers of 10 to see what happens. 3,000 divided by 10 is what? 300. What is 3,000 divided by 100? That would be 30. The values of these numbers keep getting less and less. What will we get if we divide 3,000 by 1,000? 3. Dividing followed a similar pattern, except our values were decreasing, and the digit shifted to the right for each power of 10. We already know multiplication and division are inverse operations, or opposites, so it makes sense that the digits would move in the opposite direction. Now let's get into some decimals. Start with the number 3. Shift the digit to the right one place value for each power of 10 you're dividing by. Pause here and try this out in your guided notes. Let's check our answers. We should have 3/10, 3/100, and 3,000. Again, the values are decreasing, and the digits shift to the right when we divide by powers of 10. We should practice one more thing today, and that's not just where the digit goes. It's also how these powers of 10 affect the location of the decimal. Let's start with the number 3 again. When we have whole numbers with no decimal parts, we don't typically write the decimal point, but we need to remember that it's still there. So this 3 in the ones place has a decimal point directly after it. Similar to how the digit moves left and right, the decimal point also shifts when we multiply or divide by powers of 10. To do this, we'll start with the number 3 and count how many times the decimal moves to create the new number. Oh, hey, Mia. What's that? You've got a training tip for us that will help with shifting the decimal? Oh, that's a great way to keep track of the decimal. Just like with place value jumps, the number of times the decimal point shifts is equal to the number of zeros in the power of 10 we multiply or divide by. For 10, there is 1 0, so the decimal moves 1 time. 100, 2 times for 2 zeros. And 1,000, that makes the decimal shift 3 times. The decimal will shift to the right when we multiply. We can keep track of the placement of the decimal by drawing scoops, one for each place value we are moving. And then we will fill in any empty scoops with zeros as placeholders. Let's try this out. Remember, the decimal in a whole number is right after the ones place. So if we start with 3 and multiply by 10, we move the decimal one place to the right, fill in the empty scoop, and get 30. That makes sense because 3 times 10 is 30. What about if we multiply by 100? There are 2 zeros in 100, so we will shift the decimal to the right 2 times. Draw and fill in the empty scoops, and we get 300. If we quickly check the math, 3 times 100 is 300. Remember, we're moving one place for each power of 10. So if we take 3 times 1,000, the decimal shifts 3 times to the right, giving us 3,000. Following this same pattern, what do you think will happen to the decimal when we divide? Well, if the decimal moved to the right when we multiplied, it should do the opposite, move left when we divide. Pause here to complete the table by shifting the decimal to the left for each power of 10. How did you do? If we divide 3 by 10, 100, and 1,000, the decimal does shift to the left for each power of 10. leaving us with 3/10, 3/100, and 3/1000. Excellent work! Your challenge still awaits. You've learned everything you need to know in order to master this challenge. Complete it, and the Place Value Patterns badge is yours. Good luck, Math Masters! Consider these 6 numbers: 5,000,000, 500,000, 500, 5, 5/10, and 5/1000. How does the value of the digit 5 change in each number? What patterns do you notice as the digit 5 shifts places? How are these patterns connected to multiplying or dividing by powers of 10? Pause here to complete the challenge in your guided notes. Use everything you've learned today to show your mastery. Even though the digit 5 is in every number, its value changes depending on where it is. In 5,000,000, the 5 has a value of 5,000,000. But in 500, its value is only 500. And in 5,000, it's just 5,000. As the digit shifts one place to the right in the numbers, its value is divided by 10. Each time it moves one place to the left, the value is multiplied by 10. This is because our number system is based on powers of 10. This pattern helps us understand how place value works in both decimal and whole numbers, and we can extend this pattern to multiply or divide by powers of 10, such as 10, 100, 1,000, or more. Great job, Math Masters! You solved the Math Mastery Dojo Challenge and earned your next badge. So, what have we learned today? We learned that every time a digit moves one place to the left, its value becomes 10 times greater. Every time it moves to the right, it becomes 10 times smaller. We also know that when we multiply or divide by powers of 10, the decimal point shifts to the right or left. Multiplying by 10 moves the decimal one place to the right. Dividing by 10 moves it one place to the left. You've earned the Place Value Patterns badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice applying place value patterns using powers of 10. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time. Hey, hey.